Hello, today's lesson is about solving differential equations using method for exact. Okay, so let's define what is exact differential equation. Given that you have first order differential equation of the form m of xy dx plus n of xy dy equals 0, it is an exact differential equation if the partial derivative of m function in terms of y is equal to partial derivative of n function in terms of x. And the solution of this differential equation is mu of xy equals c, where mu x of xy is equal to the integral of m function dx plus phi of y. So we just need to focus here, okay? Phi of y, because phi of y is the constant of integral, okay? And we can get it by using this formula. Phi of y equals the integral of n function minus the partial derivative in terms of y of the integral of m of x y dx, right? This m function. So to make it simple for you to understand this, I have these quick tips, okay, or general step, so that you can solve for exact differential equation. So let's try to first identify the m function and n function. Next, check for exactness. So if it's exact, so the partial derivative of m in terms of y is equal to the partial derivative of n in terms of x. Okay. Then once it is already once you consider it as exact DE, so integrate the m function with respect to x. Next is differentiate it with respect to y, so partial differentiation, okay, in terms of y. Next is you need to equate it to our n function, okay, whatever the result, equate it to n function, then solve for phi of y by integrating it, and the result will be the final solution. Okay, just write the final solution well. So here's an example so that you can easily understand it. So given that we have 2x plus y quantity dx plus x plus 3y squared quantity dy equals 0, so let's determine first the m function and n function. So as for m function, we have 2x plus y, and for n function, we have x plus 3y squared. Doing the partial derivative of m with respect to y, so we have y, we have 1 here, okay? So any variable, right, aside from y will be considered as constant. So we're just simply differentiating y here, okay? So if you differentiate y, so you will give us 1. Next, it should be x actually. So partial derivative of this in term with respect to x, okay? So all of the variables, aside from x, will be considered as constant. So x, so the derivative of x is 1, okay? And then this 3y squared, is considered as constant. So derivative of constant is 0. So we have n sub x, it should be x. So it's a typographical error. N sub x equals 1. So therefore, it is an exact differential equation because the m sub y.
I'm not quite sure how to help you with that.
So it is a differential equation. So this is an exact differential equation because the m sub y and n sub x is equal to 1. They are equal. So proceed. Okay, proceed with this step. So we need to integrate the m function and as well as this m function. So integrating it, so we have 2x plus y dx. So the integral of this will be x squared plus xy, and just simply add this phi of y. Okay, this one. Add this from your result. Next, integrate. Partial rather. Okay, partial derivative with respect to y. Whatever is your result here, okay, you just need to do the partial derivative. Okay. So we have the partial derivative of x squared plus xy. So this will give us x, and then just copy this, okay, from phi of y. So this becomes phi prime of y since we already differentiating. Okay. After that, whatever is the result earlier, so we just need to equate it by n function. Okay. So you have x plus phi prime of y equals our n function, which is x plus 3y squared. Further simplify, so this will give us phi prime of y equals 3y squared. Then integrate it so that we can get the value for phi of y. So this will give us, or this will be the integral. Okay. So this will give us phi of y equals y cubed. So this value will be inserted or substituted in our original, okay, original equation here. So this one, in order for us to find the solution of our exact DE, so we just need to get the integral of m function plus add this phi of y, the value for this equals c. So we have x squared plus xy, so this is the integral of our m function, plus the value of phi of y, which is y cubed, equals c. So we're just rewriting our final answer, and this is our final answer. Another example. So let's say we have here, okay, we have y prime equals x minus 2y all over 2x, and this y prime, if we can write it as dy over dx equals x minus 2y all over 2x. Further rewriting, so we have x minus 2y quantity dx minus 2x dy equals 0. So this is the form that we want, okay? And from this form we can now identify the m function and n function. So for m function we have x minus 2y, and for n function we have negative 2x. Apply the partial derivative so that we can get know if this differential equation is exact or not. So the partial derivative of m with respect to y, so we have negative 2, okay, and partial derivative of n in terms of x, it should be x again, it is also negative 2. So since they are equal, so therefore this is an exact equation. And applying the process, solving exact differential equation, we just need to first get the integral of our m function. So integral of our m function, and that is the integral of x minus 2y dx, and the answer will be x squared over 2 minus 2xy, and just simply add the phi of y. here. Okay. Next, we get the partial derivative of our result with respect to y. Okay. So the partial derivative of this one, the partial derivative of x squared minus 2 x squared over 2 minus 2xy. So that will be negative 2x, and then just copy this phi prime of y. Okay, whatever is the result, you just need to whatever is the result, you just need to equate it to our n function. Okay. We have negative 2x plus phi prime of y equals negative 2x, right? Negative 2x is our n function. Further simplify, so our phi prime of y equals 0, and to have an answer, phi of y, we just need to integrate both sides. So this will give us phi of y equals c. So going back in our original solution, okay, so for the format of our solution for this exact, so we have u function equals the integral of m function plus the phi of y equals c. So substitute those values. So we have, for the integral of m function dx, so we have x squared over 2 minus 2x, okay, and then since our phi of y is 0, so disregard that. We can now disregard. Okay, and our final answer here is x squared minus 4xy equals c. So what happened here is we just eliminate, okay, we just remove the 2 here in the denominator by simply multiplying the equation by 2. Okay, this is the final answer. So that's all. So I hope you learned something today, and have a nice day ahead.